Hello, thank you so much for coming. So a bit about, let's start with the poll. How experienced you guys are with machine learning? Please choose the appropriate answer. Let's see. Okay. Okay, interesting. So we have some people that are already applying it, which is good. Some people who are still new. It can change. Yeah, okay. Okay, but Andrew Ng is not here. That's fine. So, a bit about myself. I'm a software developer. I'm very passionate about machine learning. I did my bachelor in computer science in Tel Aviv. And over a decade, I was working in different companies, in banks, in international banks, in small startups. And then a series of events reminded me how fragile we are, how mortal we can be. And this really motivated me to make some change. And so I left my job and I went to Paris to pursue an academical degree in biomedical engineering. I went to a school called CRI. It's part of the Paris Descartes University in Paris. This is an interdisciplinary program inside the university where they take people from different academic backgrounds, for example, computer science, molecular biology, pharmacology. They put us all together and make us try to find a new topic to research about as a team, as a group. This was quite an amazing experience. We learned a lot from each other, and that was my first experience with computational models and machine learning. What struck me the most is how much we do not know, how much we don't know about our own body, about medicine, about pharmacology, about creating new medicines, about how our body functions, how it works. During my studies, I did one of the projects that I did was involving computer science with immunology. And for this project, I had to learn by myself immunology, how this works, more or less, and come up with an idea for a project in this combination of both programming, development, and medicine. I came up with an idea that involves Brownian motion from physics, the stock market prediction, and mutations in the HIV RNA. And when I presented it to the professors, first they were really impressed that I could learn in one semester all these topics. And then they told me, we already did it last year. We already created this model. So I realized that there is a problem of keeping up to date with the information, especially with the academic information. My professor told us, to the students, when you get these newsletters from papers from journals like PLOS, BMC, Bioinformatics, PNAS, this is not spam. You need to go over them. You need to read them. You need to look at all these abstracts and titles and decide what is relevant for you. Read it, learn it, keep current with what is going on. When it comes to machine learning, which was my next goal, there is much more around. There are many more papers coming up every single day, and it becomes much more difficult to keep current on this topic. So at some point I did some kind of a switch from computational biology to natural language processing. First, I want to help other people to find how to find new papers, how to find interesting information. In machine learning specifically, the most important things, in my opinion, is the forum in Reddit. It's a great source to find papers, interesting papers, relevant papers, hot topics about machine learning. DistilPub, it's a blog. It's a very interesting one. And I would also recommend to read the Technology Review by MIT. It's less technical. It's more like a newsletter. It's more like a newspaper. It's still interesting and gives a lot of different aspects, also from medicine and other aspects. Two more things I would like to point out is Short Science. It's not really about machine learning. It's more general. What they have there is summary of other papers, so it's really nice to have it if you don't have the time to read everything. And the last is Sci-Hub. It's the Pirate Bay of papers. I don't have a link because the URL keeps changing, but when you are not in the university and need to pay for a paper, then this is kind of an option, but use it on your own risk. Newsletter is another great way to keep information, to get information. I would like to point out the Wild Week in AI. It's made by a journalist called Danny Britz. Unfortunately, he doesn't do it every single week. Data Machina is now the most currently going every week. The problem with the newsletter is that someone needs to take care of them. Someone needs to curate them, find them every week. They always ask for support, ask for Patron, but sometimes they just give up and stop sending the newsletters. Another great source is the community. So following people in Twitter, especially the big names, is a great location to find really interesting papers. You can also enroll in Google Scholar, following someone. The problem with this is that you get everything that is quoting this person, everything that's quoting these names, so you need also to filter through this. Of course, NIPS, ICML, and ACL, these conferences are great sources also to find the papers that are being submitted to these conferences. And filtering engines. So there are several filtering engines where you can search for papers in them by keywords, by relevant papers. For example, Archive Sanity Preserver by Karpathy. It's an open source project where you can find papers according to similar keywords. They're using TF-IDF as an algorithm to find the keywords, to find similar keywords. Deeplearn.org is an amazing site. They have a section for Twitter, they have a section for the papers, hot papers, very recommended. And if you are doing research, Mendeley and sites you like are good locations, especially when you have enough papers. I think the minimum is 20 papers that you have on a topic. They start suggesting you papers from other researchers that also added the papers. So it's a very social recommender system in a way. And last but not least, semanticscholar.org. This is a project by Alan AI, Alan Institute, where they use NLP algorithms in order to find other papers that are similar to the papers that interest you, to the topics that you were after. But all of this was not really enough for me, and I was lucky enough to join some meetups. I joined one specifically called the Vienna Data Science Group. And by joining them, they have a very special format where everyone can come up with an idea, everyone can come up with a project. They present it to the community, other people can join to this project, and together can create something. And so we did. We created a project called Keep Current. It's an open source, and it's hosted in GitHub. The idea is to bring the papers back to you. So instead of letting you search for the papers, we want to bring them to you. It is done when you are saying you are supplying at least three different papers that you are interested in, and we are using the engine to find more papers. I did not do it alone. I had great help from Vladimir and Thomas. They are here today. And together we were sitting sometimes doing small hackathon in cafes and trying to get this project up and running. So what do? We are using a crawler, and we are connecting to APIs of websites, of journal websites, of blogs, in order to locate content. Then we are using NLP engines. We are using NLP algorithms in order to classify these documents and find how relevant they are to the topic that you are after. Then we are summarizing them, and we are sending you a newsletter, or also in the website, as a list of summarized topics, summarized items. And the most important, which none of the other websites so far gives you, we let you the ability to react to them, to make the algorithm adapt to your liking. We are developers, so let's talk a bit about the architecture and how it works. We have 4 different repositories at the moment. The 5th one is coming up soon. It's divided to the database engine or data engineering, the web, which is a single page app. At the moment, it's written in Angular 6. We are checking the options to move to React. We have the crawler, which uses Python crawler and also calling to APIs of REST APIs of websites. And the most important thing is the Centrifuge. This is the engine that divides the relevant documents, relevant papers from the rest. So how does this work in short? We're using different algorithms. We started to implementing, for example, the TF-IDF. Our next in line is going to be an ensemble of the text rank rake and take, based on the paper from last year, actually. Besides the keywords extractions that we used in order to find similar documents, we are also using probabilistic topic modeling, which is, in a way, it's a clustering of different topics under one umbrella. For this, we're going to start with LDA. There are already some new advances in this topic, but the LDA is still the best basic for them all. After we get similar documents, we are moving them into the social recommender system. We use several things for this, not only social, not only based on other users, but also on the distance of, for example, of the vectors in the vector space using word embedding and doc2vec. Besides, of course, we're using collaborative filtering, so social recommendations from other people. And we also want to implement contextual bandits. That's the next one in line, which is more or less like reinforcement learning, but not exactly. It's the new or the next advantage of A/B testing, but in a smarter way. So if we can call it A/B testing on steroids. The UI is also the most important thing in this topic, because eventually we want to bring it to the people, to the researchers, to the developers. And we want to get your feedback. We want the model to adapt to you. You need to train the model to make the next results better for you. After we implement the first versions, there is still a roadmap, and we want to continue. The most important topics that we want to implement afterwards is the model rationalization. This is a new topic relatively, only started, I think, last year or in 2016, where we don't treat the models any longer as black box. We want to understand, for example, if the model gave a paper to you, if he recommended a paper to you, why? Which elements, which reasons did it have to give you to recommend this document? For this, there are two main algorithms on the line. One is called LIME. You can find the paper. I will also share the presentation afterwards. And the second one is reasoning, based on Regina Barzilai's work. We want to try to highlight, for example, which keywords made the algorithm bring it to you, in order also for us to understand it better and to improve it over time. We don't want to only limit this project for research papers about machine learning. We really want to extend it even more, to bring information also, for example, for front-end developers about the new advances in this topic, for database, for back-end developers about new databases, new algorithms, new ways, or even improvement in this topic. But we need your help. This is an open source project, and everyone can come and contribute. So we really invite all of you to join us. On the way, you can also use it to learn machine learning. We are very nice people. We are always happy to help people to get into this topic. We welcome everyone who wants to join and help. We are going to host today a workshop. It's going to be the first meetup in a series of meetups by WeAreDevelopers. Today it's going to be hosted here in the Congress in room number 231. This is going to be hands-on natural language processing. We want people to come and brainstorm about how algorithms work, how machine learning is working. You are all more than welcomed to join us. And of course, you're all more than welcome to join us on the project. There will be a series of meetups, also about the project, but also about other stuff, how to keep current, and we want to help you to keep current with your field, also offline and not just online. Thank you very much.
Thank you, Liad. That was really good. I think we got a whoop as well. Who whooped? It's a dream team.
Yeah.
We have just a couple of questions, but I have a load of questions. Let's start with your questions first here. Would result personalization?
Great question.
He's faster than me.
Well, yes and no.
Yes.
Obviously, personalization slows down the project. The whole core, the whole engine is extremely computationally expensive at the moment. To be honest, my utopia, my dream was first to bring it for free for everyone, and everyone can use it, but this is a bit utopia, and then I realized when I saw the prices of the hosting, I kind of get back and said, okay, maybe you can choose one topic to follow, and then we maybe find a way to do it later with more topics. Obviously, the more people we have, the more computationally expensive it gets. But in addition, the more people you have, the recommendations get better. Because the more you train the system, you're helping other people also to be using the same model which is being trained by you. So there's, of course, pros and cons for everything, but this is how this works.
So, but in that context, how do you avoid it being people who read this also read this?
There are two options. So this is a very classical recommender system. Besides using this social recommender system, we can use also other new models. One of them was the bandits I said before, which is like an A/B testing. The model is being trained according to your answers, and it doesn't really give you only the documents, only the papers that other people suggested. So architectural speaking, if we get a bit more technical, then before the social recommender system, we have another model that takes all the inputs from all the other models as an ensemble, and then it makes the decision. So it's not just people who like that also like this document, but how it's more related to your topic and how these keywords and the other social recommendations, how both of them are affecting this result that got into your list. I hope it answers the question.
I've just about understood the question. Yeah. Let me squeeze my question in, because there's something you didn't touch on, but I think this is fundamental, is you said how do you learn and where do you learn, but when do you learn?
Mm-hmm. So to decide what is new is quite easy. When you have a crawler, then you know the stamps of every document, especially when it's a publication, then there's always a date, publication date. We know exactly when it was submitted and when it was approved and published. So this is easy to detect. The question of what you do not know is more difficult, and this is why we need your assistance of training the algorithm. So the more you are asking, the more you are responding, the more you react to the adaptation, the better it gets. In the workshop, we are going to give you some questions, and one of the questions is something very similar. We want you to think with us. How can we decide if a certain tutorial, certain document, if it's for beginners, if it's an advanced level, or if it's an expert level? This is a question we still don't have an answer to, and we would like to brainstorm on it also with you in the workshop today.
Let me just, that's very good. Let me just jump in there though and
Sure.
follow up with a question. How do you stop yourself just spending your whole time reading papers? Because you have to actually implement something as well, don't you?
Yeah.
I mean, this shows you what you could read and what you might should be reading, but how do you know what to dose? How do you dose the amount of information?
There is a way to read papers. One doesn't have to read the whole paper first. You need to decide first if the paper is relevant to you. The way I read the paper, I start with the title, and I stop, and I try to imagine what this paper is about. Then I'm looking at the pictures, at the charts, and again, I'm trying to understand what it is about. Then I read the abstract, and then I start to read the paper. But this process also helps me to filter out which papers I'm going to read and which papers I'm not going to read. And the second thing, especially in machine learning, you can read the introduction, you can read the conclusion. The whole part of the mathematics, the whole part of the implementation of the model, you can leave for later. Only when you understand that this paper is indeed relevant for you, only then go into the implementations and try to understand what the researchers were doing there.
And do you do that?
I don't have a choice.
I mean, for me, it sounds a little bit like the Twitter problem. You see something on Twitter, and you think, oh, that's good, I'll read that later. And then you don't.
No, you shouldn't procrastinate. You need to, when you are in the mood of reading the papers, you need to read the papers.
So yeah, but in that context, do you reserve a time every day?
Yeah, absolutely. Every morning. I even use my drive, travel in the U-Bahn every day to work. I have my tablet. I read on it. It's much easier than on the phone. PDFs on the phone are really horrible. We need also to solve this.
You are infinitely more disciplined than me. I couldn't do it.
Right.
Okay, let's get a couple of more questions. We do have a few more minutes, and I just waffle. You're an interdisciplinary researcher, aren't smart ML-based movements? Aren't they moving you towards one research? Is that clear from you?
I think, if I understand correctly, you're talking about the bias of the recommendations of.
Where's Ivan?
You're talking about the bias of the recommendation that the system would give you, that it will keep you in the same topic, right? And won't let you out into a different subject. If this is the case, this is a great question. We want to introduce a threshold inside the system that will be adaptable by you. So the less the threshold is, for example, if you just ask for 90% accuracy or 90% relevance, it means that the algorithm has still space to go out and find other things from different scholarships. One of the things that I'm really interested in these kind of topics, and one of the motivation that I had to do this kind of project, was that I wanted to have influences from papers from other scholars on my scholar. And I give you two examples. There is a very famous paper of Japanese researchers. I think it was Kanamori in 1980, and he described how to predict the seismic waves of earthquake based on a model of infection disease spread. And these are the things I'm after. These are the things I want. This is why I want to have a model that can search in other disciplines, not just in machine learning, but also go out to other disciplines to get this inspiration from there. And this is one of the most important, that I want to have this threshold to also get something that is from the other side, to get some inspiration from other topics, other disciplines. Great question.
Thanks, Ivan. Is there an advantage to training your own NLP model rather than using cloud ML APIs?
Oh, we are not just using our own not just using our own NLP models, because to train them are computationally expensive. There is absolutely a possibility to use, and we are using, it's called the transfer learning. We can just take an already pre-trained model and adapt it to our needs. This is completely fine, and yeah, we absolutely can do that as well, and we do that as well.
Okay, maybe one more. Can you see that?
Well, yeah, so the question is, was the decision to de-black the box, de-black box the engine, was it in order to change it or purely to make the result more explainable? The answer is both. The only way to make the models better is to understand why they gave this result that they gave. So in order for us to help improving them, the only way is to understand why they were given. So yeah, both answers on this.
Now, Mr. or Miss Anonymous has been sticking here with the book question, so we're going to do it and then we'll be finished. Does it work with books? Well, if they're online, sure, but where did the question come from? Come on, there's no anonymous in this hall. Hey man, what do you mean?
Can I just give it like a book from Amazon or stuff like that, or is it, what sources can you use for it?
So the question is, can you use it on any book that's on Amazon, or what sources would it refer to?
So at the moment we are using the open sources that we have, for example, archive.org or blogs or anything that is open. We don't have anything yet that can actually take stuff that are behind paywall. It might change in the future, I don't know, but at the moment this is the case. There is a second problem with books, the length. So at the moment we are dealing with somewhat shorter documents, so up to I think 10 or 20 papers was the most. And this is already quite expensive to model it or even to vectorize it in order to find the distance. When it comes to books, we didn't try it yet. We can think about it. You're more than welcome to join our workshop and we can discuss it as well.
It's got to happen though, isn't it? I mean, at some point in time, books will be indexed and yeah, okay. I think we'll wrap it up there, Liad. That was really good. I mean, thank you very much.
Thank you very much.
Great. Thank you. Really good.